Today I will present about Go and SQLc. And who am I? I'm Miroslav Koukal. I'm a Go developer here in Pure Storage for a year right now. And before that, I had various jobs in various companies on various positions. But everybody has history. So I will go directly to the subject. What is SQLc? SQLc generates fully type-safe idiomatic Go code from SQL, which means that we start with SQL, not only queries, but definitions of the schema, tables, triggers, types, and stuff like that. From that, we run SQLc according to its configuration, and we get our Go types and Go functions that are pretty much easily able to communicate with the database. It's really easy to use. There are basically only 3 files that you need to configure, and they're basically self-explanatory. There is no by default migrations using SQLc, but you can use other database migration tools. We use Golang Migrate, and I will talk a little bit about that later. And currently, only 3 database servers are supported, which is MySQL, PostgreSQL, and SQLite. And we are using PostgreSQL right now, so my talk will be mostly around that. There is supported SQL package selection, which is PGX v4 or v5 for database SQL. The default is database SQL. We choose to use PGX v5 because there are some more functionalities that are supported. It should be a little bit faster. There is pooling, and one of nice things that is supported in there is using JSONB as database type, because early in our project we really didn't know how the database will look in the end. Some of the columns were pretty much defined, but like half of it was a little bit foggy. We knew that we need to store the data and we need to pass the data further, but we didn't know if we will ever need to do something without it. So we chose just not to create complicated database schema if we don't need to do anything with it. Dump it into JSON and then forward it when we need it. And SQLc can emit the JSON tags, which is like super useful when you want to use it in REST APIs. And I will show a little example right after 3 slides. So yeah, that's it. I choose to compare it a little bit with GORM because it's completely opposite approach to working with databases, because SQLc, as I said, is SQL first. GORM is ORM library, so you basically want to control the database through the code and avoid working with SQL if possible. Different approach. Yeah, so SQLc might be faster. It all depends on how complicated your database is, how complicated your queries are, how you write your code, and stuff like that. In SQLc, you pretty much know what will happen in the database, but because you explicitly state it, right? In GORM, if you're a really experienced GORM programmer, I assume you also know what will happen, but yeah. There is separation of Go and SQL. So basically, all your SQL queries should lie in the configuration of the SQLc, and you shouldn't call like raw SQL statements anywhere in the code. Why? Because it will be messy. And you can easily separate users for CRUD and DDL, since SQLc doesn't do any migrations, and you need to materialize the manipulation of the schema through something else. Like I said, Golang Migrate probably. And for that you can be pretty sure that the application can only do the CRUD when you run it. It doesn't have, you don't have to give it any more privileges than that. Downside, you need to know SQL, but there is a workaround around it. I'll talk about it later. And you need to figure out how to handle migration, which I will show you a little bit later. GORM has wider support of database backends. You can see those files that I named there. You can make joins easier for you, reloading code data. It can do migrations. So you can basically create your schema as you go. And there might be some performance overhead. Again, the amount of the overhead depends on the complexity of your schema database and how many data you have there. Basically, with each version that I figured out, GORM says that they improved the performance overhead and improved the speed. So I wasn't able to find like any definitive answer on the benchmarking. Usually they say the SQLc is faster, but I was able to find some other. And yeah, it can lead to less optimized queries. Again, can, not will, but the choice is yours. With SQLc, you need to handle migrations, and Golang Migrate is a nice tool for that. You have a version control of your database schema. It can do up and down migrations, which is basically route and rollback. It has a command line interface, and it also has library support, so you can actually control your schema from the code as well. And the database support is much wider than anything SQLc or GORM. It's like threefold, I think, the database endpoints. I have a link to the GitHub page, so when you will receive the slides, you will see it. And how does SQLc work? It's pretty much straightforward 5-step process. You configure the SQLc itself. You define your SQL schema, how the tables will look. You write your SQL queries, and you generate the package and use it. Yeah, and what's better than show it on the example? I think that one example is much better than that, and I will explain a little bit about the Golang migration as well in the process. So the first file, I hope you can see it. Should I make it any bigger? Yeah. Okay. Let's see. Even. Oh, that is too much. Yeah. So you basically specify the database engine. You specify where you store your queries and where your schema is located. Name of the package and the directory where it will be located. You specify the SQL package. As I said, it's database SQL or PGX v4 or v5. We use v5 for performance. And if you want to emit JSON tags. Also, we can add overrides to the Postgres types for better working. For example, integers were as default in 32. And it can cause some problems with casting. If you override the type, then it's integer in the Go code. Then the other part, we need to create our schema. We use Go migrations. Basically, this is you need to first create some tables for the Go migrations themselves. So this first file is basically only for the Go migrations. The other files look easily. You create extensions and tables as you wish. And this is the up file that will create the tables. The down file should basically do the opposite of the up file. So, and in the schema. And if you were looking closely, you see that I didn't uninstall the extension in the down file, so it might be inconsistent. Yeah, and now the best part, which is the queries. You have to annotate the queries. Basically, this is the name of the function that will be created in the DB package. and this is how many results it will return. So you have a few options. You can return one object, you can return 0 objects, you just execute a query, for example, for deleting. You can list many objects, and you can do also some nice joins with there, which you have like specified. So when you're finished with configuring these 3 files, you should be able to start your database. So I already created an empty Postgres container, which I'll look, it's empty. Oh, magic. And I can do migrations. I have everything in the make file. So after this, I should have some relations inside my database. And this can be done, as I said, in the code or inside the init container. If you run the containerized application, so you can run before, or if you have a CI/CD pipeline, you can run the migrations before, depending on your choice. I will load some sample data so we can actually execute the queries. And yeah, it's not that complicated. Okay, we should be able to run something. So, woohoo, you can list all the people, and yeah, where are these objects coming from? Why do we know the person should be represented like this in JSON? It's in here. So you can see that I have created like 3 tables and 1 type. The type that I have created is enumeration, so is described here, and you can see that I have also like a scan function, so I can scan strings easily from the inputs. And here I have the tables, the types for the tables emitted with the JSON annotation. And in this file, basically every file that you have for the queries results in 1 file resulting with the functions, which is doing the same. And you can see that you have input type for here, and you get your result or error if you run it. So it's straightforward. Haven't run into any big issues so far. And if you are afraid of SQL because you don't like it, don't worry, we have ChatGPT. Like basically, yeah, I was lazy to write my queries, so I asked ChatGPT to do it. Like literally, as I was thinking, I was typing, do this, and it actually not only told me how should I create a table, that I should create a type as well. If you're not that good in querying the ChatGPT, you can also ask multiple questions. It's like, yeah, I need some sample data. I need them in a different way. And can you do it in Bash because I hate Python? Yes. So, okay, finally I was able to receive a Bash script that generated me all my sample data for this example. And I was really happy. So yeah, don't be afraid. I tried it. Basically, it can construct pretty interesting joins, depending on how you ask it. And I don't know if I should trust ChatGPT with the production code, but for experimenting, why not? And learning, I would definitely recommend it for learning. It can make life a lot easier. Yeah, I was pretty fast, as I was instructed to do. So any questions? Yeah.
So you write SQL and you have generated Go types, and with the scan functions, you have to write them also?
No, basically I can like if I delete DB, then I should be able to.
What my question, if you have many joins and it's not like one class or one like structure, what does he generate or?
What do you mean? What does it generate? You should return some type, right?
How the one-to-many, for example,
One-to-many? Yeah, I can show it since it's created. So you can see right here, get students. There is some join in here, and the input is like UID of a person. And as a result, you need to receive a list of people. Yeah, so it's like you append a list of the type of a person. So
the question was how it is up to the goal types.
I'm not sure if I understand. Like
I think I know how to answer the question. So it uses your migrations and your queries to generate new structs. For every query, the outputs, it knows all of the types and everything, and it will generate you a struct per query, if that's needed.
But there was models.go, there was some tracks. And it's not
It will be not on record.
Yeah, if it's possible, it is. But if you need, like, for example, if you need different inputs, then then the SQLc generates like specific type for the inputs. It can be, you can have like a query for something, and it just needs 2 parameters, so it creates a struct with 2 parameters that you need to input.
And if there is one-to-many, it will create the slice of the other objects.
Yeah.
Any other question?
Yes, I do have. So at the beginning, you've mentioned the comparison in between georm and the SQLc. So does it mean that actually you've started to work with georm? You have some experience with it as well, or not really?
No.
Oh.
No, we were choosing between GORM and SQLc, and we were just looking at the option and what we like more. And we like this approach a little bit more, but it would be interesting to have to listen to a talk from somebody who's experienced in GORM, right, Jirka?
and what was your trade-off? Is it not if it's not a secret? Why did you choose SQLc over the georm?
Yeah, we can.
Yeah,
We had the discussion.
I don't like ORM. That was the main decision on my side. Yeah, that was on my side, and yeah, security reasons are other. I don't like use the one user for DDL and CRUD. Yeah.
Okay, thank you.
Yeah, sorry.
We are close to each other. Sitting, I mean. So my question was, you generated that, you worked with that, you wrote tons of code using that. Now you need to modify your schema. How would you deal with the code that already uses the existing signatures?
Well, I don't think we ever run into it. Into a situation that we have like destructive changes, because we mostly pass the whole object as a parameters to these functions. So if you add one field or delete one column from a database, it usually isn't that big of a problem. But yeah, it depends. Like we didn't have like thousands of migrations yet in the project. We are like in bigger tens of migrations. So yeah, it can vary.
For how long have you been using that so far, if I may ask?
9 months. Yeah. Yeah, and we use repository pattern that's quite apart. And I am still in the during the design this project. I am slightly pushing others into use native Go models as the basics one, and usually database more about serialization, just and safe, and we not putting exactly logic into database. We use them directly in struct, and we have some helper functions that exactly make normal object to database one, and if you exactly need this change, you just change on one place and that should work. Yeah.
I have a simple question. Are there any problems with SQLc in real world?
Not really, but since it was new, we had to like learn a couple of things. We didn't use like Go migrations from the start. We just had an init container and where we specified on how to create the databases and the schema. We changed that a lot, and it led to a problem that we had to basically have our SQL code on two places at once. So we had to do a little bit of refactoring of that. But after we changed the Golang migrations, it was pretty much seamless. Unless you change the migration file that you shouldn't change, like basically you shouldn't modify these files once they are like released.
Yeah, for example, we adding some linting on CI that's prevent you some unwanted changes and similar things. We add SQL doc that generate automatic documentation from that. It's quite nice that you get all documentation as free.
A little bit like this.
Yeah, that's quite useful tool too. That we onboarding, we start usually a project in 2 people, and now we in the last 3 months we onboard another 5-6 people to project that we try improve documentation, including the database. This was quite useful tool, for example, that we are start using.
But to be honest, I think this tool can be used with GOM as well. You just spin up the database, do all the migrations, and then you run it to generate recommendations against the live database.
Yeah.
So there is no problem if you're using GOM.
Yeah.
So you mentioned it's generally based on the schema which you put, and if you are changing this, you can actually break something, right? I mean, in the code. So if you have been thinking about some pattern of tests, let's say,